we're going to be looking today at quadratic functions. Now, these quadratic functions, they're the squaring functions. So let's do a little bit of review on how to graph something like this. Let's say I give you f of x equals x minus 5, quantity squared, plus 3. Oh, yep, thank you, Marcus. Okay, this is the right pile here. Okay. So let's go ahead and try to graph this. Now, we learned how to graph these last time, right? And that minus 5, that's inside the operation. So it's opposite of what you think you would do. So you'd be moving that forward 5 units. And what about the 3? Okay, that's going to be moving it up. And so where are we going to be starting at? Yep. We're going to be starting at 5, right? Positive 5 because you switch your sign, comma 3. Now this is also going to be called the vertex in this case. Now, what the vertex is the highest or the lowest point. These are all going to be squaring functions, so they're all going to be in the shape of a U. Now, ours is going to be going up. Why is ours going to be opening up? Well, what number's in front of the parentheses? There's no number there, so it's assumed to be a 1, right? Okay, so where are we going to start at? We're going to start forward 5 units, up 3. So we're going to start right here at 5, 3. And what do we have in front? We have a 1 over 1. And so that means we're going to go up 1 and over 1. So we go up 1 and over 1, up 1 and back 1, right? And we make our U. Now, today we're going to be focusing only on the squaring function, only on quadratics. Now, see that 5, 3, that's either the highest or the lowest point. In this case, it's the lowest point because it makes a U. But if it was negative, it would be going the opposite way. And what we're going to be looking at is we're going to be looking at and finding the vertex. And that is either your highest or your lowest point. And then we graph it from there. Now let's do another one. Okay, one more of these. And then we'll look at one where we have to use a formula to find the vertex. Where did we start at? What's our vertex? Now be careful with this one. Right, we're going to be at 0 for the x part, right, because nothing's inside. And then what's my y component? 2. Because this 2 on the end, what does that do? Forces it up. Now what about the negative 2 here? Well, that's a minus 2 over 1, isn't it? Right, and it's in front. So that means we're going to go down 2 and over 1. Where we start at, this is also called the vertex. So in some cases, you may only have to find the vertex. In some cases, you're going to be graphing them. Right? But this one, I'm going to have you graph it, and we also had to find that vertex. Now, where do we start at? Okay, so 0, 2 is going to be at 0 and up what? 2. Now, why is this going to be a U going down? Why is it going to go down instead of going up like the last one? Okay. Right, because of the negative. So this one's opening downward. And that's what your graph looks like, right? We've done these before. We were able to get the vertex just by looking at it. Now, in some cases, we may have to do more to get the vertex. We may have to use a formula. So we're going to be finding the vertex. We're going to do one of these where we just find the vertex, like what I gave you, and then we'll do a couple of them where we have to use a formula. So on the following, we're going to find the vertex. What would my vertex be of this one? We're not going to graph it. We've done enough of the graphic for right now. If I wanted to find the vertex, right, you would have to go back 8. So it would be at negative 8, comma what? 0. And that is your vertex. Now the next one I'm going to give you is a little bit different. The next one that I'm going to give you, I've got the new homework packets for you up here. So the next one I'm going to give you, we're going to have to use a formula. Because the next ones are a little bit different. Okay, so we're going to find the vertex of this one. So this is what I'm going to want you to find the vertex of. Now, how is this one different from the others? Well, on the others, it was all a quantity squared, or we could look at it and we could find our vertex. This one's a little bit different. Notice it's a trinomial. Now, how we find the vertex is this. We find our h, which our h is going to be minus b over 2a, and then we find our k, which is f of h. And your vertex, this is a new formula, is h comma k. So this one's a little bit different because it has the x squared. We have an x and we have a number on the end. Now, how do we find the a, the b, and the c? Well, we find them the same way that we would find them for the quadratic formula. Remember when we did the quadratic formula? Okay, so we've got the a, the b, and the c here. So let's go ahead and write up our pieces. We'll plug it in, we'll find our h, we'll find our k, and we'll get our vertex. So a is 5, b is 10, and c is negative 2, right, from our formula. Okay, so let's find our vertex. Now let's use our formula for h. So h is minus b over 2a, and that's going to be a minus 10 over 2 times 5, which is then minus 10 over 10, which is then a what? Minus 1. Is everyone okay with that? Watch your signs there. Now, how do we find the k? Well, what we do to get the k, the y component, is we plug it back in. So, does someone have a question? Okay, so we plug in our value. So k is going to be f of negative 1, right? And we plug that negative 1 in. And be careful with your signs, because whenever you square a negative, what does it become? Positive. So that's 5. Negative 1 squared is 1. And 10 times a negative 1, well, that's a minus 10, minus 2. So that's 5 minus 10 minus 2, which then makes it a 5 minus 12, which is then a negative 7, isn't it? Okay, so what is your vertex now? Your vertex would be negative 1, negative what? 7. Okay, so they're pretty simple and pretty straightforward there. Let's do another one. So let's do another one of these. And then we'll look at an application. So let's do another one. And let's find the vertex again. So we need to use our vertex formula. And if we are missing the C, that's okay. So C can be 0. Yep. If there's no C, so it's going to be a 0. So let's see what we've got here. We've got our A, which is the 7. And we've got our B, which is the negative 28. And our C is not there, so C is 0. So I always like to label the pieces. A is 7. B is a negative 28, and C is going to be a 0. And now we plug our values in. So H is going to now be minus B over 2A, which is then, and watch your double negatives, a minus 28 over 2 times that 7. Double negative here makes it a positive. So that is now 28 over 14. And that reduces down to be what? 2. Okay, that's half of the vertex. How do we find the other half? We just take it and we just simply plug it in, don't we? So we're going to plug that value in. So we're going to plug in that 2 that we just found, and that's going to give us our K value. So K is f of H, and that's f of 2, which is then 7 times 2 squared, minus 28 times 2. And that's 7, 2 squared is 4, minus 28 times 2 would be a 56. And that's 28 minus 56, which then comes out to be a negative 28, right? Okay, sorry about that. I'll move it up so we can see here. And finally, what is our vertex now? Yep, watch your signs. Positive 2, because we had to switch our sign. Remember when you found the H up here. Where do students make a mistake? Right here. So you may have a double negative. You've got to make sure that's positive. You have to switch the sign. That gives you your H. And the K is negative what? 28, and that is your vertex. So finding the vertex is really not that difficult. These have all been whole numbers. Let's do one that has a fraction for the vertex. So we're going to do one now that's going to give us a fraction. So this one, when we work it out, we're going to get a fraction for the H, and then we'll have to plug that fraction in for the K. So we've got to be very careful when we work with these fractions, because they're going to appear shortly. We've got our A, our B in this case, and our C. We don't really need the C, but I label it anyways, just because we're used to labeling it. So in this case, A is 2, B is a negative 3, and C is 1. Our formula is H equals minus B over 2A. All right. Now watch your signs. So that's going to be a minus of a minus 3 all over 2 times 2. The double negative here makes that a positive, so that's 3 over 4. Now the others that we've been working with have been whole numbers. Okay, this one's a fraction, it is a little bit more difficult when we work with the fractions because we have to get our common denominators and we've got to square these fractions. So let's find our k. All right? And k is f of h. And so in this case, that would be f of 3/4. And we'll plug that 3/4 in. And that's going to be 2 times 3/4 quantity squared minus 3 times 3/4, right, plus 1. Now, how do we square a fraction? Okay, we square a fraction by distributing it through. So that square goes through the top, the numerator, and the denominator. So if we square that out, we have 3 squared, which is 9. This 3 squared is 9. 4 squared is going to be 16. And now we can work with our fractions. So we're going to reduce these down as much as we can. And then we'll get our common denominators here. Okay, so we're going to make this 2 a 2 over a 1. And when we multiply, remember, we can cancel. So that 2 and that 16, that can cancel. And that's going to leave you with an 8. And that is then 9 over 8. Right? Okay, so there's that piece. The next one is just over 1. So 3 times 3, that's a 9. It's negative. And 1 times 4, that's a 4. And then plus 1. Now, we need to combine these together. So our common denominator is going to be an 8. So I need a 2 over 2 here. And I need an 8 over 8 here. That way we can put them all together. And we get a 9 over 8 minus 9 times 2 is an 18 over 8 plus 8 over 8. And they all have the same denominator. So let's add those together. We've got 9 minus 18, that's a minus 9, plus 8 makes it a negative 1 on the numerator. And what is my vertex now? Okay, what have we found? Yep, we found that to be 3/4, right? And minus what? Yep, minus 1/8. Most of the time, they're going to come out to be whole numbers, but I did want to do one of them with you that gives you a fraction, just so you'd be aware of how those work when you have a fraction. The 3 in your homework come out to be whole numbers, so they are a little bit easier. Now I want to work with an application. And so we're going to look at one of these from our textbook, and this is going to be an application. And I'm on page 37. We're going to look at question 71. So 337, question 71. And what we're doing here is we're going to be finding the maximum or the minimum value. And that's your vertex. So the maximum and the minimum, those are going to be your vertex. And so what we've got on 71 is we're going back to a projectile problem. And it says, if an object is projected upward from the ground with an initial velocity of 32 feet per second, then its height is given by this equation. Okay. Find the number of seconds it will take the object to reach its maximum height, and what is the maximum height? So what we need to find is our vertex. Remember, the vertex is the highest or the lowest value, the maximum or the minimum. And just so we can reference that later, that's on page 337. And we're looking at question 71. Now, they give you the equation that we're going to be using here. Okay, so they give you this. They give you S of t, and that equals a minus 16t squared plus 32t. And what we're going to be finding is we're going to be finding our maximum or a minimum. In this case, we want the maximum. And the maximum is the vertex. So the maximum or the minimum value is your vertex. So we're going to be finding our vertex. And again, we have our A and our B. And do we have a C at all? Nope. So C is going to be 0. So in this case, A is a negative 16. B is a positive 32. And C is 0. And we'll find our H and then use that value to get the K. Let's go ahead and find our H. And so H is minus B over 2A. And so when we plug in our values, we get a minus 32 over 2 times that minus 16, which is then a minus 32 over minus 32, which is then a 1. Okay, so we're just finding our vertex. Now that 1, that's going to represent your, in this case, the t component, and that's going to be the time. Now we also need to find the height. So we need to find our k. And k is simply f of h, which is f of 1 in this case, which is then minus 16 times 1 squared plus 32 times 1. And that comes out to then be 16, doesn't it? So is it kind of making sense what we're doing here? Right? We're just simply finding the vertex. Now once we've got the vertex, then we can label it. So the vertex is HK, and it's 1, 16. So that 1, well, that represents the time, and the 16, that represents the height. So what's our answer going to be? It takes, so it takes 1 second to reach 16 feet. So the highest it can ever be when you throw this up in the air is 16 feet. So it's going to take 1 second for that to reach its maximum height of 16 feet. Now, the one question that you have in your homework is very, very similar. There's only one of these. And I think it deals with manufactured watches and cost. So if you look at question 7 in your homework, very, very similar. Here's your cost function. You're going to have to find your vertex. Okay? And that vertex is going to be the number of watches repaired. And when you plug it back in, that's going to give you the cost. And we want the lowest cost, and so that's going to be the vertex here, the minimum. So on that question 7, all you have to do is find the vertex and label it. Vertex is the highest or the lowest value. Now let's learn how to graph some of these. And when we go to graph these, there's certain things that we need to find. Okay, we need to find our vertex. And then we also need to find our x-intercepts, if you have them. And how do you find your x-intercepts? Well, you set f of x or y equal to 0, depending upon which one you have, because it can be either f of x or it can be y. And then we also need to find our y-intercept. And how do we find our y-intercept? Well, we simply find f of 0. Okay, so that's what we need to do. So when we go to graph these, there's three things that we need to find. We need to find our vertex. We need to find our x-intercepts, if we have any. And we also need to find our y-intercept. And that's just simply find y of 0. Okay, so we'll graph a couple of these. And we'll start off with an easier one. So let's look here at... how about question? How about question 29? I think. Well, let's not 20. Let's do 30. Okay, we'll do 30 first. Then we'll come back and do question 29. So let's do question 30. This is on page 334, and we're just going to graph this one. Okay, so page 334, question 30. We're only going to graph it. And what we've got is we've got x squared plus 6x plus 5. So we want to graph this one. And we need to follow the 3 steps. So we're going to have to find the vertex. We're going to have to find the intercepts. Now you may have to factor when you get the intercepts. And then you're also going to have to find the y-intercept by plugging in 0. So let's start off with our vertex. Okay, so there's 3 parts we have to get. Let's get our vertex here. A is 1. B is positive 6. And C is going to be what? 5. By the way, let's just take a moment to talk about this graph. Do you think the graph is going to look like this? Or like that? Which one do you think it's going to look like? Just by not doing anything else. Which one do we think it's going to look like? Yeah, it's going to be opening up. Why? Because this is what we look at, and this is positive. As long as this is positive, it is opening up. If that would have been a negative 2 in front, it would look like what? That. So you already know that it has to be opening up. So it's going to eventually look like this. And all of these are squares. This one's going to be opening up because that's positive. So let's go ahead and find our vertex now. So h is minus b over 2a. And that's a minus 6 over 2 times 1. Which is then minus 6 over 2, which is then a minus 3, isn't it? Now, how do we find our k? Well, we simply plug it back in. So f of negative 3 would then be minus 3 squared plus 6 times a minus 3 plus 5, and that's 9 minus 18 plus 5, which is then a minus 9 plus 5, which makes it a minus 4, doesn't it? Right? It's 9 minus 18 plus 5. Yep, that makes it a minus 4. So we now know our vertex, which is minus 3 minus 4, right? Okay, so there's your vertex. Is everyone okay with that? Right? We've done numerous ones of these. Now, if we want to graph this to get an accurate picture, we really need to find our intercepts if we have them. So let's go ahead now and try to find our intercepts. And let's first just go ahead and plot our vertex. So where's our vertex at? It's at -3 and back 4. Or sorry, down 4. Right? So that's going to be right here. Now, when I go to plot this, what do we know? Let's look at the picture and see if we have any intercepts at all on the x-axis. If we think about this, and I were to draw my picture, right, what's it going to look like? It's going to be a U, okay, and this is your x-axis. So if I were to draw a picture, it's going to touch the x-axis somewhere, isn't it? And it looks like it's going to have 2 points at where it touches. Somewhere over here and somewhere over here. You're going to have a U. So we need to find those. Now the next one that we're going to look at is not going to have x-intercepts. But this one has 2 x-intercepts because it makes a U, right, and it crosses at 2 places. So now let's find our x-intercepts. So what do we do to get our x-intercepts? Well, we set, in this case, f of x equal to 0. So that gives us x squared plus 6x plus 5 equals 0. Okay, so we set f of x, your function, equal to 0. Now we should know what to do. We've done a lot of these. What are we going to do from here? Okay, factor it. First times the last is a 5. What 2 numbers multiply together to give you 5, add together to give you 6? 3 and 2 doesn't work because remember we want the 6 in the middle, right? So we need a 5 and a what? Yep, 5 and 1, right? Because they have to add together to give you the 6, multiply together to give you the 5. That's going to now factor directly into x plus 5, x plus 1. And now we've got x plus 5 equals 0. So x equals -5. And then we've got x plus 1 equals 0. So x equals now a -1. What do our intercepts now look like as ordered pairs? Well, as ordered pairs, we set it equal to 0, so this is your y. So what our ordered pairs look like are -5, 0, and -1, 0. And these should make sense on the picture, because they do. All right, we have a -1, 0, which is here. We have a -5, 0, which is back here. So 1, 2, 3, 4, 5, it looks like. Okay. And so does that make a U like what it should? Yeah, it does, doesn't it? Okay. Now we have one more part to finish, but it looks correct. Just look at it and make sure that it looks right. It looks like we should get 2 x-intercepts, and here they are. Now, what about the y-intercept? How do we get the y-intercept? Right, y-intercept is where it touches the y-axis. So that's going to be somewhere up in here. We don't know where, right, but if we were to use a curve, it would touch somewhere in here. How do we find that? Well, for the y-intercept, we need to find f of 0. So we're going to be plugging in 0 into our function. And so f of 0. Well, let's write up our f of x just so we have it. So f of x, we just had that a moment ago, just so we have it here. F of x was x squared, right, plus 6x plus 5, and we want f of 0. So we're going to plug in 0. And what happens with all these zeros? Well, they go away, don't they? So that gives you f of 0 equals 5. And as an ordered pair, that is your x value. So this is going to be the y value. So what does it look like as an ordered pair? 0, 5. And does that make sense when we look at our picture? Okay. We found our y-intercept, right? That y-intercept is 0, 5. And that makes sense because 0, 5 is up here. And now I can connect these together, and I should be able to make a U. There is your completed graph. Okay, so we got our x-intercepts. In this case, we had 2 x-intercepts. We found our vertex, and we found our y-intercept. Now that one had 2 x-intercepts. The next one is not going to have any. So let's look at 29. And question 29 is f of x equals x squared minus 2x plus 3. Okay, so what are we going to have to do? Well, we want to graph this. That's going to be our goal, is to graph this. So if we want to graph this, we first have to find our vertex. If there's no number in front of the x squared, we know that's a 1. So A, B, and C. And let's go ahead and get those. A is 1. B is a negative 2. And C is 3. We want to find our vertex. So H is minus B over 2A. And that's going to be a minus of a minus 2 over 2 times 1. Double negative makes that positive. So that's 2 over 2, which is then a 1. Now we need to find our k. And how do we find our k? Our k is f of h, which in this case is f of 1. And we just simply plug it in. Okay, 1 squared is 1, minus 2 plus 3. That makes my vertex now, the k part, come out to be a 2. So what's my vertex? Yep, 1, 2. Now, this one is not going to have any x-intercepts. And we can graphically see why. Is this one going to be a U opening up, or is it going to be opening down? Which one? You think it's going to look like this or this? Yeah, it's going to be opening up. Why is it going to look like this? Thank you, Leonardo. And thank you very much. Get that graded for you. So see you two on Thursday. So this one's going to be a graph opening up. Now the last one, it had 2 x-intercepts. This one is not going to have any. And let's see why graphically this one has no x-intercepts. Well, if we were to graph it, our vertex is at 1, 2. Now you told me that it's going to look like that, isn't it? Okay, if I curve here, does it ever touch the x-axis? If it's making a U like that? No, right? Why not? Because it's opening up. And it's already above the x line. So this has no x-intercepts. And if you solved it, what you would get is you would get complex numbers. So if you went to solve this, you would have to use the quadratic formula. And if you use that quadratic formula, you would get complex or non-real numbers. And we can't graph imaginary numbers on a real line, on our axis. So you would get complex numbers, and anytime you get complex numbers, you have no x-intercepts. We do, though, have a y-intercept. So no x-intercepts because it's opening up like this. Now, if it was going down, it would have them. Okay, because it would touch and it would have two of them. But ours is going up. Now, how do we find the y-intercepts? Or, sorry, the y-intercept, because there's only one. Well, to find the y-intercept, what we do is we plug in 0. So we're going to plug in 0. And we want to find f of 0 now. And we're going to go back. We're going to plug in that 0. Just so we have it, our original function is this. Our original function, f of x, is x squared minus 2x plus 3. And we want to find f of 0. So we're going to plug in our zeros here. And what does that then come out to give you? Okay, 3, right? Because 0 squared is gone, gone. That gives you my 3. So my y-intercept is 0, 3. And 0, 3 makes sense because that's going to be right here. Right? We have no x-intercepts. We have y-intercept of 0, 3. Now, what is it going to look like? Yep, so we just kind of curve it and make it look like a U. And there's your picture. What am I looking for when I go to grade these? Well, what I'm looking for is I'm looking for the fact that it's a U. It's opening upward. And I want you to find the x-intercepts if you have them. And always the y-intercept. Because you're always going to have a y-intercept. So you will always, always have a y-intercept. Maybe not an x, but you'll always have a y. So that now finishes up 3.1. And we're now going to look at 3.2, which is synthetic division. And this is something that's new, but it's actually pretty easy to do. And 3, 1, and 2 are combined together. We're going to be now talking about synthetic division. Now, synthetic division can be used in place of long division, and it can be used to find zeros of polynomials. What I'm going to have you do is I'm going to have you use synthetic division to find the remainder, to find an answer by plugging a value in. So first off, I want you to find this. We're going to work this one out the way we normally would. So let's find f of 3, and you're going to be given f of x to be 2x squared plus 5x plus 4. Okay, so you're going to be given that f of x, and I want you to find f of 3. How would you do this? And we've done this a lot, right? We want to find f of 3, so we rewrite it with the 3. Okay, so we plug that 3 in, and then we have to square it, so 3 squared is a 9. 5 times 3 is a 15. 2 times 9 is 18, right? We have to add them all together. Okay, and then when we add them all together, we get our 18 plus plus 15, right? Plus 4, and that comes out to be 37. Now that was quite a bit of work. I mean, it wasn't too bad, but we could do that, right? And that's f of 3. Now, I'm going to do the same question, but we're going to use synthetic division. And I'm going to show you how it's quite a bit faster. And this is how a computer calculates polynomials. When a computer is asked to find a value of a polynomial, it uses synthetic division. So notice when I plugged in 3, I got out of 37. We're going to use the same process. Now we're going to use synthetic division. And you've got the same polynomial. F of x equals 2x squared plus 5x plus 4. Okay, and I want you to find the same f of 3. And that's actually now going to be called your k. So whenever you see a k, that's the number you're going to be plugging in. Now, we know the answer should be 37 because we just did it a moment ago, right? Synthetic division is going to be quite a bit easier. How does synthetic division work? Well, we make our diagram here. And what's our highest power? It's x squared. So we need to make sure all the terms are represented. So we've got x squared, x, and then I use the c to represent the constant. And that constant's the 4. So what are our values here? We've got a 2, a 5 for the x, and a 4. And we put our 3 out in front. Just like that. So whatever value they want you to plug in, you put it out in front. And we always start with a 0. And then we add down. So 2 plus 0, that's a 2. And now we multiply. So 3 times 2, 6. And we add down 11. 3 times 11, that's a 33. Add down, and that is a what? 37. And it's the same thing that we just found, right? Quite a bit quicker, though. We didn't have to square. We didn't have to do all that. Let's do another one so you'll see the big difference in the amount of time it takes. We're going to do a cube. We'll do a cube the normal way, and then we'll do a cube with synthetic division. So let's see, you're given f of x to be 5x cubed plus 3x squared plus 2x minus 8. And I want you to find f of, how about negative 4? Okay, so we're going to do this one the way we would normally work this one out. And we've got to be very, very careful with the signs. And there's lots of pieces that we have to worry about, right? Okay. So if I wanted you to find f of 4, that's what f of that negative 4, that's what you'd have to do, isn't it? Right? You have to plug it in. Quite a bit of work. Let's go ahead and work this out. Now, what happens when you cube a negative? It stays negative. Okay, and 4 cubed is 4 times 4, which is 16, times 4 again makes it a negative 64 because it's negative. And what happens when you square a negative? Okay, negative 4 squared becomes a positive 16. Now we'll just multiply. So 5 times a negative 64, it's negative 320. And then we've got 3 times the 16, that's a 48, minus 8, and another minus 8, right? We can add these all across. Okay, and let's add these up and see what we get. We have a 320 and it's negative. Add 48 to that. Take away 8 and take away 8 makes it a minus 288. Now that was quite a bit of work, wasn't it? I mean, it wasn't too bad, but it was quite a bit of work. Now, how can we do this with synthetic division? This is why synthetic division is so useful. This was the way we would normally do it. Now let's do the same problem with synthetic division. So you got the same function. And you're going to end up with the same answer. And let's find f of negative 4. And this right here is your k. So that's a k of negative 4. And in some cases, they're just going to say, like in your homework, the k. Okay, that's your k. We build our table here. What's our highest power? Cubed. Okay, so we need all of them represented. So we need a cubed, a squared, x, and your constant. We're going to put the negative 4 out in front, right here. That's your k value. And we fill it in. So we've got a 5, 3, 2, and a negative 8. And we always start with a 0. And then we add down. So 5 plus 0, that's a 5. Okay. Negative 4 times 5, what's going to go here? Negative 20. Add down. Negative 17. Okay. Negative and negative makes that a positive 68. Add down, that's a 70. 70 times a negative 4, well, that's a minus 280. Add down, and that gives you the same what? Negative 288. See how it was quite a bit easier, right? It's about half the amount of work. And you're a lot less likely to make mistakes because you're not having to worry about signs. It's already taken care of. Let's do a couple more of these. Oh, thank you. Yep, I'll get that graded for you. Okay, yep, and those two. Okay. Yep. Oh. Okay, so let's do a couple more of these. If you're missing parts, you've got to plug in a 0. So let's do a larger one. So we're going to use synthetic division, and I'm going to give you a k of, let's say, minus 2. And here's your function, f of x equals about minus 3 x to the 5th plus 4 x to the 4th minus 2x squared plus 3x plus 5. Okay, so really long one here. If I was going to do this by hand, that would take a bit, right? Because you'd have to plug the negative 2 in. You'd have to take it to the 5th power, then to the 4th power, then square it, and plug it in here. Now, this one is missing a term. Yep. And so when we write it, we always start with the highest power, which is, in this case, x to the 5th. So we need x to the 5th, x to the 4th, x cubed, x squared, x, and then the constant value c. And our k goes out here. So the negative 2 goes right there. Now, if you're missing a part, you're going to plug in a 0. So we've got a minus 3. We've got a 4x to the 4th. Do we have any x cubes? Nope. So we're going to put a 0 here, right? And then we've got a minus 2. And then we've got a 3. And then we've got a 5. Okay. So make sure you put the 0 in. Now we're going to add down. Right. So make sure you put the 0 in. And we're going to add down. So that's going to give you a minus 3. What's going to go here? Can someone tell me? Let's see. Yep, minus 2 times minus 3. That makes it a positive 6. What goes here? Add down. That gives you a 10, doesn't it? What's going to go here? Negative 20. What goes here now? Adding down. Negative 20. Okay, what goes here? Looks like 40, doesn't it? Yep, because 2 times 20 makes it a 40. What goes here? Yep, 38, right? And negative 2 times 38. Yep. Yep, and it's a, watch your signs, minus 76, isn't it? Add down, what comes down here? Minus 73. Okay, what goes on the last part here? Negative and negative makes it positive. And that's a 146. Add down, and that gives you your final answer, which is 151. So that is your answer. And what is that now? Okay, that is f of a negative 2. But if you would have done this by hand, we would still be writing it out. Right? We'd still be trying to cube and square. Let's do one more of these. And this will be our last question for today. So I'm going to go ahead and pass out the sign-in sheet. And this will be our last question for today. Here's the sign-in sheet. So let's do one more, and this will be the last one of today. Okay, again, let's use synthetic division. And I'm going to give you a k of minus 2. And here's your function. Make a larger one here. All right. And you only have 3 of these questions in your homework. And this looks very, very similar to question 9. It's just question 9 isn't missing any parts. This one is. Okay. Now, we wouldn't want to have to plug in a negative 2 because that would take a long time. We would have to plug it in. We'd have to take it to the 6th power. We'd have to take it to the 5th power. We'd have to cube it, square it, add 8, all of that. Synthetic division, and this is where synthetic division is really, really useful. Synthetic division is going to make this a lot easier. So our highest power is x to the 6th. So then we have to go and make sure all the parts are represented. And if you're missing any components, then you've got to plug in a 0. And our negative 2 is going to go out in front. So the negative 2 goes right there. And let's see what our values are. We've got a 4. We've got a 5 here, because that's x to the 5th. Do we have any x to the 4ths? Nope. So that's a 0 there. We have a 4x cubed. We have a minus 5x squared. We have no x's, and then we have the number 8, don't we? And we always start with a 0 and add down. That starts the pattern. Okay. Now, let's take our time, work through this one. What do? Multiply and add down. Multiply, add down. That's it. So, 4 times a negative 2, negative 8, add down, negative 3. Negative 2 times negative 3, add down, 6. Negative 2 times 6, that makes it a negative 12. Add down, negative 8, right? Negative 2 times negative 8. A negative makes it a positive 16, doesn't it? Yep. And then negative 5 plus 16, that's a positive 11. Negative 2 times 11, that's a minus 22. Add down, that's a minus 22. Negative and negative makes it a positive 44. And when we add down, that gives you then a positive 52, isn't it? Because 8 plus that 44, that makes it a 52. So what is our answer? 52. Now, we can do that without using a calculator, right? We didn't even use a calculator. Okay, we didn't even use a calculator at all, and we was able to do all of that. If you would have been doing it by hand, and you would have been plugging in that -2, you'd still be setting it up. That's why synthetic division is so useful. It has other uses as well, but I think the most useful one is for evaluating polynomials. Okay, so if you've got homework, you could turn that in today. If you want to turn in the homework from last time, from chapter 2, if you want to turn that in on Thursday, you can. And I've got everything graded. So I'll put your old graded homework up here for you to pick up. So all your graded homework is over here. Does anyone still need to take the exam from